All right, so we are in day 16 of the course. Today we're going to go ahead and learn about a couple things. The first thing we're going to learn about are dictionaries, and hopefully, time permitting, we'll go ahead and return to memoization in the context is a idea used in recursion. Lois or Caroline, do you want to show off the lights? Is that would help you all? Thank you, or at least the ones from up here. All right, yeah, that should be a little better. Okay, so we need to go ahead and learn about what a dictionary is first. That's a nice little data structure. And by the way, I don't know if I've used this word in here yet, but a dictionary is a type of data structure. And again, it's exactly what it's exactly what it sounds like. It is some sort of structure that holds data. List is a type of data structure. It is just a sequence of data of objects. So a dictionary is a little bit more going on with it. So what I would, of course, encourage you to do is look at the documentation, and we'll look at it in a little bit, but let's just go ahead and play around with it a little bit. So a dictionary is more general than a list. So if you think about a list, let's kind of think about let's say we had just my list, and we had something like 1, 2, 3. How did we access, say, the second piece of information? If I wanted to go ahead and just print out the second piece of data that is stored in my list, how did I do that? I just used this little bracket notation, and in there, what did I put? 1. So again, I could go ahead and print that, and it is going to print the number 2. So really the only change for dictionaries is instead of having this be a tied to integer indices, we can go ahead and use any sort of non-iterable. So like we can start, let's say we wanted my list, and we wanted to use a key of some sort of string, we can go ahead and do that. But again, it's more general because it's basically a list where we're not tied to using integers as a way to access the elements. So a dictionary's, so I'll just kind of say it like this way, a dictionary's elements are accessed using a key. When you access the element, it gives you, using the key, it gives you a value. So there's you'll hear me say throughout the day, the key value pair. So the key up in this list was just number 1 was the key, and it gave us the value of 2. So again, let's go ahead and first learn the basic syntax. So if we were to initialize an empty array, so excuse me, I've been dealing with arrays with my homework. Initialize an empty dictionary. The way we can go ahead and do that, and let's maybe provide a context here, that let's go ahead and make a dictionary that translates English to Spanish. So we'll call our dictionary English to Spanish. There's 2 ways to do it. The way we can go ahead and do it is just using this notation right here, dict, D-I-C-T, with parentheses. This has some really nice, this one has some advantages in how you can go ahead and initialize it, and we'll maybe look at the documentation later. Maybe the easier one that's more familiar for what we've been working with is we could also just initialize it by using braces. So either of these will initialize an empty dictionary. I'm going to go ahead and use the second one because it's a little bit more succinct. And again, this one has some other advantages to it that you can see in the documentation. We'll look at maybe a little bit later. So I'm going to just comment this top one out for now. All right, so how do we add an element to the dictionary? So let's go ahead and add elements to a dictionary. And we're going to do that by simply using that index kind of bracket notation. So English to Spanish. And let's go ahead and let's keep it with the numbers. So the key to access a certain value is 1, and then the value will be the word uno. And now if we go ahead and print English to Spanish, let's go ahead and just run and see what we have. You can see right here, we have one pair where the key is 1 and the value is uno. So if we went ahead and wanted to add another number, so let's say 2, and let's go ahead and assign to the value, or the key of 2, the value of dos. And now you can see if we were to go ahead and print this, there are going to be 2 elements in our dictionary, as we can see right there. Notice again how this looks when we print it. This colon is essentially saying number 1, this key goes to uno, this value. That's one entry in the dictionary. The comma separates that, and then this right here is the second entry in the dictionary. To get this value, we would just use the bracket notation, and we would just not use the equal to, we would just go ahead and print it. So let's go ahead and make sure we know how to access it. So let's go ahead and, let's go back, didn't mean to do that, accidentally went backwards. So let's go ahead and add one more element here. So English to Spanish. Go ahead and, before I do it, go ahead and put 3. And by the way, 3 in Spanish is tres, T-R-E-S. There's my 3 years of high school Spanish paying off, right? I can remember more than that, not much, but. All right, so it's just a matter of doing parentheses, or not parentheses, quotations 3 and equal to trace. And let's say you just want to go ahead and be like, okay, we've set this all up. If we want to go ahead and access just the third value trace, we can go ahead and just pass in the key of 3. And notice when we run this, it will print the associated value. What happens though if I were to do 4? Anyone want to guess? At least y'all know. It's an error. This is a key error. So if you try to access an element, or access the dictionary using a key that is not defined, you'll get a key error. So of course that means you have to be careful when you're accessing a dictionary and looking for a value from it, so that you need to maybe do a quick little check first. So we'll talk about that in a moment. Any questions so far? By the way, let's suppose that you want to already have some of this pre-populated. This is a little bit tedious. So another way that you can go ahead and do this would be as follows. You can just go ahead and just, instead of initializing it to an empty dictionary, you can just go ahead and put the key value pairs in. So like 1 and then colon to separate its, the key to its value would be uno. And then you would have a comma, and then you would have 2, and it would go to dos. And then you would have a comma, and then you would have 3, colon to get the key to the value would be trace, and so on. So this would be good if you remember from the earlier projects, like sometimes we had different grammatical structures. This is a good way, like you can go ahead and put the different grammatical rules in a dictionary, and you can use that to pass around information a little bit more easily. And then if I went ahead and run this, let's go ahead and just put 3 in here, and you can see that it will again print trace. So that is one way, or you could just initialize it with some values. By the way, pretty common thing to do to make this a little bit easier to read is to go ahead and put it on multiple lines. So you can see right here, this will also be fine. If you wanted to break it up over multiple lines, it just makes it a little bit easier to read from a programming perspective, so that helps readability a little bit. Any questions so far? Okay, so Next thing, let's go ahead and just erase that. Let's see, I'm gonna go ahead and just erase this because we don't need it. And again, I will post all these in the notes. So the next thing I want to make sure we know how to do is to iterate through dictionaries. There's a little bit more to it than with lists because you have to consider there's keys and then there's values. So let's go ahead and just iterate for entry in this dictionary into Spanish. Let's go ahead and just print the entry and see what we go ahead and get when we were just to iterate through this right here. So if we run this, we go ahead and get 1, 2, 3. So what are we technically iterating through when we iterate through the dictionary? We're iterating through the keys. So keep that in mind. So if you just try to access this into Spanish and you just iterate through, technically there's also a method that's implicitly being done, that we're iterating through the keys. So that's also good to know. Like if you need to check, remember we said there like you don't want to accidentally introduce like a error. So if you want to go ahead and check, like let's say print 4 into Spanish, you can do that and you can see that's going to be false because it's checking if that value is a key. And I should say, carefully use the word value, it's checking if this string is a key in this dictionary. So now let's suppose you want to iterate through the values. We can go ahead and do that as well. All you have to do is just change this using the values method. So I'm going to change this to value to make it clear. So for value in into Spanish.values. And by the way, remember that this is a method, which is a function on a class. So I do need to go ahead and put parentheses to call it. And you can see I can also iterate through the values. There is another option, and that is to say we can iterate through both of them at the same time. One way to do that would be as follows. You can always just go ahead and do something like for key into Spanish, and you can say the value is key or into Spanish, and then you can just pass in the key, and let's go ahead and print the value. So this is one option right there. So that's where you could basically, let's do it like this. So let's do it together so you can see there's the key and the associated value, just using this kind of idea. But this Python Python programmers and developers, they don't like to talk a lot. So if you're ever talking to a Python programmer and they're like not talking a lot, it's probably because they're used to like really shortening it. So what you can do is just put 2 variables in the start of the for loop, and then you can just iterate through the items. So this is kind of the last way to iterate through a dictionary. For key, value into Spanish.items will allow you to go ahead and essentially get those paired together for you automatically. So a couple nice things there for you. By the way, this idea right here, let me see if this will tell us, does it give me more information? Let me check. All right, so I don't think it will tell us I was checking if the IntelliSense would tell us. This idea where we're doing 2 variables as we go through one kind of object, this items right here is returning a tuple, an ordered pair. So this idea we're doing right here is known as tuple unpacking, is we're taking a tuple and we're unpacking it. The first part of the tuple will be stored in key and the second part of the tuple will be stored in value. So again, if you hear in the context of Python, they say tuple unpacking, it's something like this right here. This is returning a tuple and we're just unpacking that tuple into 2 different variables. So that's iterating through dictionaries. Any questions? Okay. After the break, I hope to get into some visualization using matplotlib and maybe some other plotting programs. So one nice little piece of statistics, and I was doing a project with a thesis student named Johnny, I don't know, maybe like 4 years ago. and we were doing an analysis on chess. Basically, the problem we were looking at is what is the probability that a black would win if black took the white queen first, or if vice versa, if the black queen was taken first. How does that affect the probability? So again, we had to do some counting just to kind of, and we actually got a huge data set of about 10,000 chess games and just kind of see how things played out. But as we iterate through a lot of data, we might want to go ahead and do some counting. So dictionaries could basically be viewed as a collection of counters where the key is talking about some sort of event, and then the counter is, again, some integer that's saying how often it occurred. So the way we can go ahead and do this, by the way, in statistics, essentially we're creating a histogram. So let's go ahead and write a function called histogram. And what we'll go ahead and do is pass in a string. So maybe not, we're not going to worry about a 10,000 data set, but the problem we're looking at right now is suppose you are given a string and want to count how many times a letter appears. So this is the kind of the problem we're looking at right now. And by the way, part of your next project, Project 3 Wordy, is two cryptography problems, Caesar and Vigenère. And one way to basically crack kind of ciphers or crypto systems is using a word letter analysis. And anyone want to take a guess what the most common letter in the English languages in words? I think it's E, actually. And so if you're looking at some sort of like message that has a lot of Q's or something, Q's don't occur often, so it might be that Q is supposed to go with E. So that's something that to be aware of. So again, we're going to just do a little counting problem right here. We're going to make a histogram. So essentially what we want this to do is it's going to take some sort of string and is going to return to us a dictionary. So there's the type hints just to kind of help us understand what our goal here is. And the word that, so ultimately we're going to store our histogram. And I'm going to go ahead, this is what we're going to end up doing. Let's say the word I chose here earlier was parrot. And we're going to go ahead and fill out this function to get us a histogram where the string is parrot. So think about this for a moment. What do we ultimately want here? What are our keys going to be? So if we're going to return a dictionary, what is our key going to be? Anyone? So, okay, good. That helps me understand that we're still don't quite have the problem on it. What are we trying to do? We want to count how many times a letter appears. So our dictionary is, if we think about this, we want to know how many times P appears, how many times A appears, how many times R appears, how many times O appears, and how many times T appears. So our keys here are going to be letters. And associated with letters, so again, we're ultimately going to have, again, just put this in a comment if you want. So we're going to have the key of P, and then what do we want our dictionary to be when what is the value going to be associated with P if we were looking at parrot? 1. And again, what if we wanted to go ahead and how many A's would there be? Also 1. How many R's? 2. And how many O's? 1. And how many T's? 1. So this is what we want our function to deliver to us, this dictionary. Does that make sense? Okay. So how can we do this? We could go ahead and just declare a dictionary. I'm going to just call it D. And again, remember, don't ever call your dictionary dict, because that is a function. That is basically the casting function. But so I'm going to just call it D, and I'm going to make an empty one. This one's a little bit of a tough problem. Let me give you maybe 3 to 5 minutes just to play with these ideas a minute. See if you can make any progress. See what issues you run into, and then we'll go over the construction of this function together. About another minute, and then we'll go over it together. Has anyone run into a key error yet? That's what I always run into when dealing with dictionaries. You got to be careful with how you add items and. All right, let's look at this together. So this is how I approach this. Typically when I'm writing a function, the first thing I want to do is maybe I'm going to go ahead and just print S so I kind of understand what's coming in here. So if I run this, let's go ahead and see what we get. Not much of anything because there it goes. Oh, by the way, I'm going to just comment that out. So we get parent. So, okay, I see that a string is coming into this function. And if I'm going to go ahead and create a histogram, or I want to count them, I need to go ahead and iterate through all of the different letters. So let's just do for CH or character in the string, I'm going to go ahead and iterate it through it. And we did a problem like this before, if you think about when we were counting A, B's, and C's. So we were basically declaring a bunch of variables ahead of time. So would you do something like, so we need num of first letter, and you can see where this would get a little bit tricky. Like how many letters are there? Do we start, and then how do we initialize a bunch of variables? So if you ever find yourself in a situation where you're like, I feel like I have to initialize a bunch of like counting variables, that is a good indicator to say, hey, I'm going to encapsulate all of that into a dictionary. So that's kind of what we're looking at here. So kind of the naive thing would be maybe to like, okay, so in my dictionary, I know that letter is going to be increased by 1. So you might do something like this first, and then if you go ahead and I know when all that's done, return dictionary. So all I'm going to do here is just iterate through the dictionary and add 1 using the letters as a key. And of course, I get that wonderful key error. So of course, implicitly, remember this notation is saying we're trying to do this. So what we're trying to do here, or what's the issue is we're trying to access an element before we've actually put a key for that in there. So that is there's a couple ways to get around this. The first thing that I would think to do is, of course, do a quick check. So if the character is not in the dictionary, let's go ahead and just make that character 1. So like this is the first time you've encountered a letter. So let's go ahead and just see what we get if we do this. So okay, that's awesome. That's good. So this is pretty close. But oh man, I hate off by 1 errors here. Here we are. We have an off by 1 error. We don't have enough R's, which you kind of expected because all we're doing is just setting the value of 1 to the first time we encounter a character. So the second R, we basically just set it back to 1. So the other thing we can do is just go ahead and set an else statement. And because if it is in there, we are able to safely access it. So the dictionary with key of character, that's when we'll go ahead and increment it by 1. And then you can go ahead and return this. That is exactly the function we're looking for. So big takeaway here, make sure you always check this, make sure you always go ahead and check that a key is in the dictionary before you try to access it. So any questions on that one right there? Okay. By the way, if this is annoying, which it kind of is, there is a nice method with lists, or excuse me, with dictionaries. So let me just kind of point out, this is the documentation. I'll have it linked in the notes, so I'd encourage you to read it. We've gone through a lot of these ideas right here, but maybe a couple things that I just want to point out before we talk about one last thing for the day. Yeah, we have about 10 minutes, maybe 2 things. We'll see how it goes. You do have dictionary comprehensions. So you can see here, this is a dictionary comprehension, same thing as a list comprehension, except for a single variable expression. You have a key value expression right here. So those are nice. Remember I said earlier that this other, Guido, by the way, that shows up a lot in the documentation because Guido von Rossum was the initial designer of Python. So it's not just a funny word, it does have some meaning in the Python community. But again, as I mentioned earlier, when the keys are simple strings, so this might have been this would have been a scenario like it's just a letter or a string. If you use that dictionary function to go ahead and create the list, you can kind of make it a little bit nicer just using this syntax right here where it basically is implicitly going to cast some variable to a string. So that's kind of cool. So the other thing that you'll want to spend some time with, as mentioned last time, whenever you get a new data structure, so again, a dictionary is a type of data structure. It's also sometimes referred to as a hash map or has different names in different languages. Just read through the documentation. Like you'll see, like there's a bunch of things right here. You can go ahead and cast you can go ahead and cast it to a list, which of course returns just the keys. You lose the values. You can go ahead and use the length function. You can see right here, there's in and not in. The one that I want to go ahead and call out that's a little bit funny at first is this get method. It is a method. This get method right here. We'll go ahead and read what it does. It returns the value for a key if key is in the dictionary else it has a default value. And again, if the default value is not given, it defaults to none. So this is a nice way to safely access a dictionary using this method instead of using the bracket. So this function right here, I can actually rewrite getting rid of this block, this if else block, and I could just change it to one simple line to say the dictionary at C, again, I'm going to try to access, well, not C, we're using CH, sorry. The number we want to access right here is going to be D, and we're going to go ahead and get that character. But if that character does not exist, let's just go ahead and make it 0. And so this right here is going to try to get the character's current value. If it does not, it'll just default it to 0. And then what did we want to do? Just increment it by 1. So that if-else block could be shortened to this little statement right here using the get method. It's a nice, safe way to access dictionary keys if you're not sure if it's in there, or access values if you don't know if the key is in there. So that's a fun little exercise just to kind of get our minds around how to work with dictionaries more. Any questions? So Anna, you posed a great question last time that I thought about a little bit more, and I just didn't think about it when you had asked it, but like, why do we pass by reference? Dictionary is another thing that you could pass by reference, and I don't think I said something like this last time, but let's go ahead and just look at this little example right here. We'll look at it in the context of lists. They're just a little bit easier notationally to wrap our head around. And again, they're passed by reference. That is to say, if you go ahead and kind of set it equal to it. So if you were to do something like so if you were to do like, so if you were to say referenced, I'll just say ref hist, just to kind of get in our minds around what we talked about last time, and we cast that and we set that equal to hist. Remember, ref hist does not actually contain a copy of the histogram. It contains a reference to the original one. So any changes you make to ref hist will also affect hist. Same thing happened with lists. Another advantage to that kind of reference idea is that you could encapsulate certain actions into functions, and then you can go ahead and document using functions as well. So let's look at what happens as we step through this. So if you look at, first we have in our global frame, we have A, which is a list of 1, 2, 3. Then we're going to go ahead and define this function f. And by the way, what does that function f do? No trick. Just okay, it appends 4 to a list that was passed in. So again, notice we haven't called it yet. We'll call that next. So we're going to go ahead and hit next. And now notice it jumps back up to the function, and now it's going to call it. But notice here, this list that is inside the scope of this function is pointing to the same one that the A is pointing to up here in the global scope. So I can go ahead and notice, does the F return anything? Technically it returns none. So remember, there's always a return. So it does return none. So if you were to print F of A, it would return none. But notice that we didn't do anything to our list outside of the function. We just went ahead and still did all of the work inside the function, and you can see that we get the result right here. So this is nice because it allows you basically to encapsulate a bunch of logic that does one thing and just put it in a function, call that function, and it's going to just do all the work within that function and not necessarily clutter up global scope or anything like that. So that is nice because it allows us to go ahead and work with just kind of store data in something outside of a function. So let's go ahead and just get into our minds one last thing for the day, and I want to quickly review the Fibonacci function. So remember, not rib, but fib. Y'all look tired. Well, okay, I think let's You're all tired of watching me. That's what it is. So let's see. Can you remember how to go ahead and do the Fibonacci function recursively? I just want to get this problem back in our mind at the end of the day. And then we'll talk about memoization next week. But it's a good application of dictionary. So how would you define your Fibonacci function? And by the way, let's say I want the nth Fibonacci number. So of course, if I pass in 1, so just if you don't remember, fib of 1 is equal to 1. Fib of 2 is equal to 1 as well. Fib of 3 is the sum of the previous 2. So again, that's the pattern. So fib of 4 would be 3. Fib of 5 would be 5. Fib of 6 would be 8. Fib of 7 would be 13. All right, so this was the recursive implementation of the Fibonacci function, that if you get n1 or 2 passed in, you can go ahead and just return 1. Otherwise, you need to go ahead and get the sum of the previous 2 elements of fib. And by the way, for I in range, well, let's just do it this way. For n in range of, let's say the first 10 Fibonacci numbers, we can just do fib, let's go ahead and print fib of n. So you can see right here, let's see if that works. It does not. Why not? If fib is equal to 1 or 2, return 1. Oh, did anyone catch my error? I got this. Off by 1 errors. Happens so easily. I didn't have anything to catch 0. So technically, we could also say, if n is less than or equal to 2, that should catch it. Yeah, there you go. So here is the first 10 Fibonacci numbers. Kind of breaking the rules here. I could have also just done something like that. Yeah, question.
Isn't that assigning fib of 0 to 1?
Yeah, this was a nice little catch case to get rid of the error really quick. But yeah, technically fib of 0 is not defined. Anyway, I wanted that bug gone. So that is the Fibonacci function. You all remember that? So by the way, if anyone remembers, let's kind of leave with an example, and we're going to go through the actual memoization next time. Go ahead and try printing fib of, pick a number that's reasonably sized but not too large, like fib of, what'd you say? 50. If we go ahead and do 50, you know what? I didn't even check that. That was too large. Like for this, let's say we did 32. I go ahead and run this. It didn't take too long. Let's try, so it doesn't seem too long. What if we want to do 36? Well, now we're awkwardly staring at the screen, right? Still waiting. You wouldn't think that just adding 4 more numbers would make it this much longer. By the way, if you want to know how to time something, let me show you how, and then I'm going to show you how long memoization will take. So what I'm going to do, from time, import time. Yes, I wish I could import time to my life that easily. Time is a function that is essentially going to grab the clock. So start is equal to time. And now what I'm going to do is do end is equal to time after that function is done. And I'm going to go ahead and just print end minus start time. And then let me put this in seconds, so seconds. So now let's run it. How long did you guys, anyone count while I rambled? Like how long that took? All right, so let me just show you the difference that memoization can make. Let me just copy it over. We'll kind of talk about this next time. All right, so 36 took us 4 seconds, right? By the way, let me do it with memoization now. I'm using n equal to 35. So it's running. So n, the 35th Fibonacci number, using the implementation that we just went over, gives us an error. That's awesome. Let me go ahead and correct that really quick. Memo fib. It should be memo fib. Where is the... Sorry about that. Oh, right here. Memo fib. How long do you think it'll take? Took 35 3 seconds, so here it is. It took us 3 seconds to do fib of 35. It took us about a 10,000th of a second to do that same number with memoization. But if we were to do 39, well, this will take us a few seconds here. I think it's going to take us about 20. But anyone, how long do you think it'll take with memoization? Oh, it didn't change. Hold on, 35. Oh, that was a weird bug. Anyway, I don't know. It's behaving a little bit funny right now. What's copying and pasting always is a little bit funny. Anyway, memoization is these are the tests I ran before class that it took about, so 39 took me about, hold on, where is it? There, this is what I did before class. So 35 took me 3.39 seconds, and with memoization, it took me 0.000038 seconds. So we'll learn about memoization next time. Over the weekend, go ahead and read Project 3's description, maybe start playing around with it. I haven't gotten on Replit.com yet. I'll go ahead and get that in over this weekend. I just want to work on the starter code for part 4. And then if you have some questions, let me know. But after memoization, we'll kind of talk about the projects and just work on the problems you run into together next Wednesday. Sound good? All right. Enjoy your long weekend, and I will see you all next week.